Okay, in previous session we discussed Little Indian, Big Indian, ASIC, memory, etc. So in Little Indian, what happens? Lower byte will be stored at the lower address, right? In Little Indian style, lower byte will be stored at lower address, and in Big Indian, higher byte will be stored at lower address, right? The different way of storing data into memory, based on that you got Little Indian and Big Indian style. Then we discussed load store architecture. Load store architecture means, or you can say the instruction, load store instruction will be helping us to move data between register and memory. Load means from memory to register. Store means register to memory. Right? Then we discussed instruction pipelining. Instruction pipelining is nothing but overlap execution of instructions. Right? Say one instruction will be in fetch phase and another instruction will be in decode or execute phase. That is nothing but instruction pipelining. Because of that, you will be increasing the performance of the controller or processor. Then we discussed ASIC, application specific integrated circuit. So that is meant for some particular application. So you'll be building that from the scratch, you can say. Then we discussed programmable logic device. So in that you got fixed logic and programmable logic. Fixed logic means once programmed, you cannot change that one. That reprogramming of the device is not possible. Then programmable logic device like your FPGA and CPLD. So you can reprogram those devices. So difference between FPGA and CPLD is FPGA is made up of like millions of gates. So because of that, performance will be more. Whereas CPLD is made up of like some 10,000 of gates. So because of that, speed will be relatively less compared to FPGA. Then we started with memory. So program memory or ROM, read-only memory. So it can be mask ROM or it can be PROM, that is programmable read-only memory. These are one-time programmable, or it can be EPROM, E square PROM, Flash, NV, RAM. Then we started with RAM. RAM is RAM is volatile. Volatile means when you disconnect the power supply to this RAM device, and the content of memory will be destroyed. So this random access means you can access data randomly. It need not to be in a sequential form, or it need not be in a, you need not to traverse in a continuous location, something like that. Randomly, you can pick any memory location. So here it is read and write. Right? So this RAM can be read and you can write to the this RAM. So it will be used for holding some temporary result variable, or it is said as working RAM. So under RAM you got three types. One is SRAM, that is static RAM, and another is DRAM, dynamic RAM. Then last one is non-volatile RAM, or can be considered as ROM also. Why it is known as non-RAM ROM? I'm telling means you behind some small battery that will be continuously providing power to RAM. So when RAM has got power continuously, then it can retain the memory content. It can retain that content in the memory. So because of that, it is known as NVRAM, non-volatile RAM. So static RAM is fastest of all these things, right? So because of that, this will be used in your cache memory. Whereas dynamic RAM, there you have to refresh that circuitry. I'll be explaining in coming slide what do you mean by refreshing that dynamic RAM. Because of that, it will be slower compared to static RAM. So one bit of information to be stored in static RAM, it will be requiring 6 transistors. Whereas in case of dynamic RAM, one transistor and one capacitor is enough for storing one bit of information. So I will explain this one, read and write operation of static RAM. So here this is nothing but this is one inverter and this is another inverter. They are connected back to back, and these 4 transistors will be responsible for holding the 1 bit information, right? Then I told these are nothing but your access transistor, access transistor, and this WL word line. Through this word line, you will be controlling the access transistor. Then bit line and bit line bar. This will be helping us to read data from this memory or write data to this memory. Read and write. Right. So first we will be writing data to this memory location. So I want to write 1 to this memory location. So I will be writing 1 to this bit line. I will be writing 1 to this logic 1 to this bit line. Right. So this is 1. Then to write data to this memory, this word line should be held high. Means this word line should be made as 1. When this word line is 1, this transistor both will be on, conducting. That is, you got gate supplied to this transistor as well as this transistor. So this will be conducting. Means this 1 will be coming over here, or you can say it will be reflecting here 1. Right? Here I am doing write to this memory location, first operation. Then we'll be seeing the read operation. So write means I want to write 1 to this memory location. For this purpose, this bit line will be acting as the path, or through this bit line I will be sending the value I want to store it to this memory. So 1 I am writing here, and this word line should be held high when you are writing data to this memory. So high means this is on. So this one will be coming here. Then this one will be connected to this point now. So here also will be 1. This PMOS transistor will be off when you have 1 at the gate of this PMOS transistor, right? So this NMOS transistor will be turned on when you give 1 to the gate of this NMOS transistor. So this is off. This is off and this is on. On. So when this is on, this is off means, see, this is connected to VDD to this point, right? But this transistor is off means you will not be getting that voltage here. But here this is on. On means this is connected to your ground, so it will discharge here. Means you will be getting value as 0 here. Getting 0 because there is no connection from VDD to this point because this transistor is off. Now this 0 will be given as input to this inverter now, right? This is another inverter. So this 0 is connected to this point. Now this transistor will be, can anybody message me what happens to this transistor when its input is 0 and this transistor? You can message me. This transistor will be on, good, and this transistor will be off. So this will be on now, on, and this will be off, off, right? On means, this is on means VDD to here, connection is there here. So then this will be now 1, right? So I wanted to write 1 to this memory location. So 1 is circulating here. So it will be circulating between this inverter. So this 1 is stored in this memory location. Is it clear? I wanted to write one to memory location, and this one will be stored in this memory location. Now I want to write 0 to this memory location. 0, right? 0, and this bit line, word line should be 1 only. When this is 1, this transistor is on, so you will be getting 0 here. Right? Now can you people analyze this one? What happens to this transistor, this transistor? Again, you'll be getting 0 over here. Tell me what happens to this transistor. Say this is M1 transistor, or T1, something like that. This is M2. M2. Say this is 3. And this is 4. Now message me what happens to M1, M2, M3, M4. M1 on, good. M2 off, correct. Yeah, when M1 is on means VDD is connected to this point. So you'll be getting 1 here. Now this one will be coming this point. Now what happens to M3 and M4? Yeah, it's correct. M1 will be on, M2 will be off. Next, M3 and M4. Yeah, message me. What happens to M3 and M4? Good. M3 off, M4 on. So M3 off means no connection from VDD to this point. But this one will discharge through ground. So what value will be getting here? 0. 0. Right? So I wanted to write 0 to this memory location. So this 0 is stored. Or this 0 will be circulated here. Is it clear? Any doubts? So this is writing to your memory, right? Next we will see reading this memory. So reading this memory, right? So for that purpose, again, your word line should be held as 1 only, right? Because this access transistor should be on in order to access data from this memory location. So for that purpose, this word line should be again held 1. Who is this? What is this man? Huh? Again, one more guy started. If you are not interested, you can leave. Huh? So we'll be seeing the reading this content of memory. So assume some data is stored in this memory. Say m is equal to 1. That is logic 1 is stored in this memory. Right? We are reading this content of memory. So we are assuming 1 is stored in this memory location. Right? So for that purpose, old line should be 1 and your bit line and bit line bar both should be 1 to read data from this memory. Getting, I'm assuming logic 1 is stored in this memory location, and we want to read that value. For that purpose, your old line should be 1, and in order to read data from memory, both bit line and bit line bar should be 1. Right? Bit line and bit line bar should be 1. So assume this is your Q output point. This is Q bar. Q means that is say 1, logic 1, and Q bar is 0. We are assuming 1 is stored in this memory location. Say so Q is 1 and Q bar will be 0. Right? Now this is at 1 and this point will be again 1. Right? We are assuming this point to be as Q and this will be 1. So there is no potential difference between these two points. So because of that, it will not be discharging, means it will be having the same voltage level. But here this is at 1 and this is at 0. Q bar is 0. Means because of that, it will be discharging this thing. Through this path, it will be bit line bar will be losing its voltage. Right? Through this path, it will be losing its voltage. Then next step, we will be giving bit line and bit line bar as input to one sense amplifier. Right? So this bit B and B bar, that is bit and bit line bar. This bit line I'm calling B, this bit line bar B bar will be given as input to one sense amplifier. Sense amplifier or comparator, you can say. Right? There it will look for the values of bit line and bit line bar. If bit line bar is going down, if bit line bar is voltage is going down, then the output of the sense amplifier will be output of this sense amplifier will be 1. Output of this sense amplifier will be 1. Right? So here bit line will be same as 1, but bit line bar will be losing its voltage value. So because of that, the sense amplifier output will be 1. So we will be getting the value 1 from this memory. Right? So we assume 1 is stored in the that memory. So we will able to get the value 1. Is it clear? Is it clear? How we are getting 1? Both bit line should be made 1 to read data from this memory. Then we are assuming logic 1 is stored. So Q will be 1. So there is no potential difference. But here Q bar is 0. There is a potential difference and it will be discharging through this path and it will be losing its value. So bit and bit line bar will be given as input to sense amplifier or comparator, then there it will be checking whether bit line or bit line bar is low. Based on that, it will be giving the output. Next, you people analyze with respect to say 0. In memory, logic 0 is there, and we want to access that value. Memory 0 is there, and we want to access that one. Again, for that purpose, word line should be 1, bit line, both bit line should be 1, and Q bar. Now Q will be 0 and Q bar will be 1, because we are assuming this memory contains value 0. Right? So now here it is 1, it is 0. So potential difference, so it will discharge. Here 1, 1, it will not discharge. Then we'll be giving bit line and bit line bar as input to sense amplifier. Now your bit line is decreasing. Your bit line is decreasing, then sense amplifier output will be 0. Right? If bit line is decreasing, the output of sense amplifier will be 0. Is it clear? If you want to do like this, then it will be a problem for you people only. So many people will be seriously coming for this one, understanding purpose, not for doing time passing. So this is the static RAM. So whatever I explained, that thing is there. Then dynamic RAM. So dynamic RAM stores data in the form of charge. So here they are made up of mass transistor and one capacitor. Right? So it consists of only one transistor and okay. If you have class, then we'll wind up now here itself. If you're doing like this, no, it's not required you people to join. Yeah, you got class, right? You can leave. Yeah, you got class, right?